Hi everyone, I hope you're doing well. This is the third lesson of our second unit, and today we're going to move a bit beyond measures of central tendency and focus on another really important descriptive statistic, which is looking at the spread of the data. We'll have lots of examples to give you in order to see why this is important. But just a reminder, what are the three measures of central tendency? Those are the mean, median, and mode. So if I had a bunch of quantitative data, I would probably start to look at those things first. But sometimes you're limited by just that. For example, if you look at these two data sets below, the mean of both of the data sets is the same, 66.5. But how do these two data sets compare? So we want to have more information in order to start to talk about the distribution of data. So if you just look at the numbers, you can see here, I don't know what the lowest, 19 might be the lowest for data set 1, and the highest is 99. In data set 2, are they in order? Yeah, they are. The lowest is 54, and the highest is 88. So the spread of the data is very different between the two data sets. So I would say data set 1 has a larger range or spread, and data set 2 is more clustered, closer to the mean. So using those descriptions is great, but as I've talked about already, you really need numbers to back these things up. You actually want to have some sort of statistical measure to say, oh yeah, the spread is like this big, or things like that. And that's what we're going to focus on for a couple days, because there's actually a bunch of different things you can do for what is called the measures of spread in stats. So measures of spread, often equally important to the averages. It really indicates how widely the data is dispersed. So how big the range is, and then a whole bunch of other things like standard deviation, and we'll see some other ones as we go through. So it indicates how close the values are clustered around the middle values, so those mean, median, and mode. And when you get further in stats and talk about things, start talking about confidence intervals and things like that. And so less spread means you have greater confidence that the values are going to fall within a particular range. And so we get closer and closer if we can reduce that spread down when we're trying to make estimates and things like that. So if you were making an investment in money, you may be just as concerned with the measure of spread on your return as you are with the average of the return, right? So if you were to invest some money and they give you an average return, let's say, 5%, but some years it might be -5 and some years it might be 15%. That's pretty important to know. Whereas if you had something where it was like either 4 to 6%, it makes a big difference in terms of the measure of spread and your comfort level with your investment. So just a simple example that you could see the use of this. So there are a bunch of these things. I said one, the range, which we've already talked about a little bit. But today we're going to talk about more the interquartile range, and then box and whisker plots. And then next class we'll talk about some standard deviation and percentiles. So the range is simply the highest value minus the lowest value. So the range is useful. It's just limited, but so you take your max minus your min. And so when you look at graphically, and I've got an example here, you look at graphically, you can see examples where there's a large spread and also a small spread. So the small spread will be stuff like this. So this would be a small spread. And then a largest spread would be the blue one here. So this would be more spread out. Even though they all have the same average, the spread can be quite different. And we'll look at lots of different examples. All of these are what are called the normal distribution that we'll talk about later on. So first one we're going to look at are quartiles and interquartile range. And we've kind of already talked about one of these things, and that's the median. The median divides ordered data set into two halves. And if you were to take each of those two halves and then chop them up in half again, these halves are divided and you would get into quartiles. So you really split your data up. So if I'm going from here to here, and let's say I cut the median here, but then I was to cut again on the lower half, and then I was to cut again here, I end up with quarters. So I get 1 quarter, 2 quarters, 3 quarters, and my 4th quarter like that. So the middle of the lower half is called the lower quartile. That's this guy, or the 25th percentile. So we'll talk about percentiles in a minute, but it really means that 25% of all the data fall below whatever that number is. So 1 quarter or 20% of the values are less than or equal to the lower quartile. If I was to go to the upper half, the 75th percentile, then you have values of 75% of all your data are equal to or below that quartile, and therefore 25% are above it, things like that. So this idea of splitting into quartiles also means that the median is now our middle part here is the 50th percentile. So we're going to talk about the spread, and sometimes we just are concerned with the middle part. So if here's the median, and here's what's called Q1, this is Q3, and here, which is the median, is called Q2. If we just look at the spread between here and here, this can change based on a data set. This part is what's called the interquartile range. So the interquartile range is the range of data. So just like we talked about, the highest minus the lowest, but you exclude the lower 25% and the upper 25%. You're really only concerned with the middle group. And there's lots of instances where this is important. I was actually worked at a school where their average they used to show was the interquartile mean, in this case, the average of only the middle 50. So this interquartile range, you'd really just take the formula down here is the easiest, Q3, and you subtract Q1 based on what you have. So lots of new terminology, but pretty straightforward in terms of what you're doing. And we're going to get to in a minute, but you can also finally have a measure where you can try to figure out if some values are outliers. And outliers are defined as being more than 1.5 times the IQR, either below Q1 or above Q3. So this 1.5, there's not really a mathematical explanation other than it means that if you were to take this number, whatever this number is between Q1 and Q3, and I was multiply it by a measure larger than 1, you're really far up here or you're really far below here. If you have data points that fall here, they are most likely an outlier. So this measure allows you to use a relative measure to the data set because you're finding it using the IQR and basing it around that. So if you had data set that was really clustered around the middle, that IQR is going to be small, and an outlier is maybe not as far as it would be as if the data was more dispersed from the middle. And we'll look at different examples, but hopefully you kind of get an idea of it. So let's try this by hand, but again, as usual, we're going to use our calculators to do this. So it says find the range Q1, Q2, Q3, and the IQR of the following data sets, and then are there any outliers, prove or disprove? So we're going to try to figure that out. So this formula, really important to know, pretty straightforward. It's given to you on the IB exam, and I think most people will just remember it anyway. So let's start here with the range. So we've got this data, so I think it's just lined up, is it? Yeah, it's lined up mostly in order. So my range, the highest, 64, minus 26, my lowest, so 64 minus 26, I get 38, 38. So there's my range. If we wanted to find the median, so the first thing we have to start with is the median, or Q2. So subscript 2 on this. So my median not equal to, but let's just put a colon. The best thing I can do is just use n plus 1 divided by 2. And so we need to know how many data points we've got. So I've got 1, 2, 3. So I got 15 data points. So I've got 15 plus 1 over 2. So that's going to be my 8th data point. So I go to my 8th data point. So that's easy. So therefore my median is going to be 41. Now that I've done that, you kind of take that one out. You don't have to consider it. Everything below, let me just change that color. Everything below and above. So now I want to split the lower half of the data and I'm going to split the upper half of the data. So if I do that, let's start with Q1. So the lower half, the lower quartile, so lower quartile or Q1. You can do the same thing if you want the n plus 1 divided by 2, but now you're only working with the lower half, which is 7 data points. So I don't include the median. So I take 7 plus 1 divided by 2, so it will be the 4th data point. And so this Q1 corresponds to this 4th data point. So therefore, Q1 is equal to, in this case, 36. And you get the idea. You don't always have to go through that process of splitting the data, but the upper half of my data, which is this section over here, it's going to be the middle data point, which in this case would be my 12th data point. So Q3 is going to be 46, just like that. So not so bad. So this is my upper quartile. And if I want to find the IQR, my interquartile range, I just take Q3 minus Q1. So 46 minus 36, which is 10. So that gives me a relative measure to this data set for my interquartile range. So every data set is going to change based on the spread of that data, if that makes sense. So that's useful because now we can take that to find relative outliers to that specific data set. So in part B, it says, are there any outliers? So what I want to do is I want to, find the boundary on the lower end and the upper end separately in order to see if there are any outliers. So let's just start with the lower end. I'm going to take 1.5 times the IQR. So let's just do that first. I got 1.5 times 10. So nice, easy math. So that gives me 15. So I'm going to then go my lower quartile boundary. I take Q1 and I want to go to the left of that, right? That makes sense visually if you think of it. Minus that 1.5 times the IQR, which is 36 for my Q1, minus 15, which gives me 21. So if there was a data point on this left side here that was 21 or less, then I would say that that is an outlier. In this case, there is no lower boundary outlier. So kind of running out of space, but let's just do the same thing, only add the 15 to Q3. So I've got upper quartile boundary. So I take Q3 plus 1.5 times IQR. Q3 was 46 plus 15. And I get obviously 61. So in this scenario, now I go over, I look, is there any number 61 or greater? And of course there is. So this, therefore, 64 is an outlier. So this is very, very useful when you're dealing with just one variable data, trying to figure out if you've got outliers without just kind of guessing and saying, oh yeah, it looks kind of a bit bigger or a bit small for this data set. This gives you a relative measure in order to figure that out. So this is something that you may likely include in your IA potentially. It's certainly something that's often on the IB exam, and it's a very useful statistical measure in order to figure out outliers. So we'll come back to that as well, but just a note at the bottom, like the median, if a quartile occurs between two values, it's calculated the average. We didn't see that there, but that's okay. So this, and I can't remember if I do it down below. No. You can definitely use your calculator. And the next one we'll just use our calculator to figure this out. But it's, I think, very helpful to use the calculator. We'll give you all the stuff except for the IQR. Maybe I'll just show it here now. So if you go input this data, just like you normally would into your lists. So let me just clear these out. So I go L1 and you just input the data. So you can try this out. And we go to the same place that you do in order to figure out the mean and the median. Hopefully I've got them inputted correctly. I go to stat, calc, one var stats. Frequency list, remember if you've still got an L2 in there, which it often will if you have your handheld calculator, delete that L2, you don't want it, otherwise you won't get the right stuff. So here you notice, I'll just scroll up, here's all the stuff we've seen before, but you can also see Q1, so quartile 1, yours probably says just Q1, 36, median it gives me, quartile 3, 46. So you can easily get that information from that, and that's really what's going to happen. That's what's expected. One of the things that becomes really, really useful to use this information is to visually represent the spread of the data. And in order to do that, most often what's used is what's called a box and whisker plot, or just short formed into box plot. And it's a strange name, but it kind of explains, you'll see below. So it's a visual display of some of the descriptive statistics of a data set. Namely, it tells you Q1, Q2, Q3, but also the minimum value and the maximum value. So it shows you all of the range and everything you could want to know about the spread. The only thing it doesn't show you is what's called the standard deviation, but we'll talk about that next class. These are often referred to, those 5 things, as the 5-number summary of a data set. So below it says, consider this data set. So they produce it, but then they show what a box plot is, and we're going to create our own in a minute. So you can see here, there's normally a dot at the beginning and at the end, and this would be the minimum on the lower side and the maximum on the upper side. So those are our minimum and maximum. And then you have, this is the whisker part, the line that goes until you get here, and this first line of your box is Q1. And then the next line is Q2, or the median, whichever you want to call it. And then the last one is Q3. So like that. And then it produces a little box. Normally this is just slightly above the number line. And then you have this upper whisker. There's some important information within this. Like, for example, from here to here, right? And this is where the visual helps. This part is 25% of the data. This part is 25% of the data. Together, obviously, that makes the middle 50% of the data. Similarly, this is 25% of the data, and this is 25% of the data. So it gives you a visual representation of how things are spread out. So down below it says the rectangular box represents the middle half of the data. That's your middle 50%, the lower whisker is 25%, and the upper is also 25%. So why don't you try this one and see if you can construct this, use that box plot as an example. But I'll just fill this in. So we'll get our 5-number summary. So I'm going to use this in order to do it, which you should try as well. Just get rid of this other data. Oops. So I've typed those all in. It's nice because you don't have to arrange them in order or anything like that, which takes so long. And on Excel, you can do this stuff quite easily as well. Okay, I'll just make sure I got everything inputted correctly. Let's see what I get for my answers. I think that's right, yeah. So there's my information. So construct a 5-number summary. Oops. So I want my minimum, which is 2, according to my calculator. My Q1, 2.5. Q2 or median is 5. Q3 is 6. And then my max is 9. And then it says find the range. That's easy. I just take max minus min, which is 7. My IQR. So I've got 6 minus 2.5. Get rid of this. So that's 3.5. And then it says draw a box plot. So I've given the number summary here. So I always just start with my min and my max. So I put a dot there. Max is 9, so I put a dot here. Then I try to draw my Q1 line, Q2, and Q3. So Q1 is 2.5. So you can see this is a really short 25% of the data because it's not that many data points and they're all clustered. Q2 is 5. Q3, 6. Like that. So you can form your middle box and then lines that extend to here. So this is Q1, Q2, and Q3. So to me, this shows that you've got a lot of the data on the lower end, and then not a lot of data spread through that 25%. If you were to imagine this thing graphically, what you have is something like this. And it is discrete, so I probably should separate these, but something like that. What that represents is that you've got this, just to connect it, where it's positively skewed. So most of my data is on the left side, or then the negative side, they call it. So there's my min and my max. And you don't have to label those necessarily, but just to give you an idea to practice it. If you wanted to, you could figure out to see if there was any outliers. In this one, I don't think there is because it's pretty tightly packed in data. Okay, so just to show you some visual, because we don't want to go through every single example of this and make it ourselves, but if you had symmetrical data like this, we would say that this is symmetrical, this one to the side. Your box plot's going to look mostly balanced. So when I say balanced, it's mostly equal in terms of each section. So most of the 25% parts, so the 2 whiskers are the same and the 2 middle boxes are the same. If it was skewed, like the example we saw, so if it was positive, you would have some space over here and your box plot would have a longer whisker potentially on the right. So that would be positively skewed, and vice versa if it was negatively skewed. Over here, you would have this section like that. Just to give you an idea of how it connects. Okay, so probably the most useful thing in box plots is to actually use them to compare different data sets and to make a visual comparison. And this is, if you were to read medical journals and often anything where there's numerical data, they'll often show box plots. It really is a commonly used visual thing to represent the spread of data. And so it allows you to compare all these things between them. So let's take this as an example here. It says, hospital is trialing a new antibiotic and has collected data on how long the new and old drugs take before the patient's infection is cleared. They wish to know which drug acts faster and which is more reliable. So remember, if you were to say, okay, well, the average of this one is this and the average of this one is this, that's one measure, and that is useful to talk about. But you also need to back it up and say, well, what's the spread of the data? For example, maybe sometimes it takes so much longer, but then in other cases it takes so much less, and so the spread is really big. You need all of these measures in order to give a comprehensive description of a data set. So we've got the old drug times here in days and the new drug times here. All of the information has already been summarized for us. So the 5-number summaries are below. So this is for the old drug and this is for the new drug. What we're going to do is make a visual comparison of these. So we parallel box plot. We just put them over top of each other. So let's start with the old drug, let's say. So I'm going to say this is the old drug. So I got a min of 6, max of 21, and we can draw in the other parts, Q1, median, Q3, like that, and then connect these up. And then my new drug, min is 7, Q1 is 8, it's really close, median 9, Q3 10. So really tightly packed box plot. And my max is 12. Like that. Great. So you can clearly see here from a visual representation, not a very good whisker plot there, but we've got a good indication of the spread of this. So the question says, which drug acts faster and which is more reliable? Use stats to support your claims. And so this is what a company might do. So even though the old drug had a minimum that was quicker, so it had certainly the quickest time, on average, we would say, the new drug is faster, as 75%. So when I look at 75%, I'm talking about Q3. 75% of the infections cleared by 10 days versus the old drug, which only 25% were cleared in 10 days. So that's a pretty convincing argument to give. You could also say 100% of all the data was cleared within 12 days, whereas it took 13 days for 50% of all the infections to be cleared. So there's different things in you. The more you give, the better support your argument is. So if I was to describe which is more reliable, again, the new drug is more reliable. And we could even use the same argument that I just said for the speed, but because 100% of infections were cleared in, what was the max? 12 days? Versus only 50% cleared in 13 days for the old drug. So different arguments you could make, but using the stats, that's why we do it. That's why we want to give that information. So it says, what could be done to be more confident in the results from the new drug? in this case, if you look at the number of data points, it's not a lot. Generally, that's always going to increase your confidence. So I would increase the sample size. And that's definitely going to help. Okay, so you can see lots of different uses. And you know what? Now that you've seen box plots, I'm sure you'll spot some different places. This is something I saw a while ago that I thought was interesting. It says there was a question: assign a probability in percent to each word or expression. So they asked a whole bunch of different people to assign a number to, for example, if I was to say, if you gave a percent to this expression, almost certainly, what percent would you give? So down here we have the assigned probability or percent. And if you see here, here's the lower end. So Q1 was 90%. So 75% of all people said 90 or greater percent to that expression. And if you enjoy language as well as math, you can kind of appreciate this kind of stuff. Or if something was probable, then most people probably would say, everyone said above 50%, but most people said above 60%, 75% of all the people. And some of these dots you can see out here, often if something is an outlier, for example, highly likely, and somebody answered, 15%, clearly they misread the question or whatever, and I probably wouldn't include that in. And so in this case, you can see they didn't include it as a minimum. They've left it out here. Sometimes they'll even put an X like this to show that it's an outlier. And so you can kind of look through that if you want, if you're interested in it, but that kind of thing for sure. Okay, so if you have any questions, let me know. Otherwise, just try these practice down here. It's not a lot. It looks like a lot, but it's not too much. And we'll take them up next class. Okay, we'll see you soon. Bye-bye.